Hello, everyone. I'm Chris, and I'm the Deputy Director at the Massachusetts Green High Performance Computing Center. Can you guys hear me okay? Is that better? There we go. All right. So I work on several cross-cutting projects regionally and nationally around cyber infrastructure and workforce development. And the project here I'm talking to you about today is a national effort called the Open Storage Network. And much like most projects in this space, we have our own three-letter acronym, or TLA. So I'm going to use the term Open Storage Network, or OSN, interchangeably. So data is growing at an alarming rate, right? Whether that's telescopes or microscopes collecting data at unprecedented scales, sensors or IoT devices aggregating data, or you taking disparate data sets and aggregating them to do training, the need to capture, store, share, and analyze data is constantly increasing. And so the Open Storage Network originally focused on data sharing, but as you'll see throughout my talk, we've sort of adopted and provided other solutions as people expressed interest in doing more with the storage network. And so to think about OSN, let's take a step back and look at the United States research cyber infrastructure ecosystem as of today. So within the National Science Foundation's portfolio of services, they do a really good job of providing local, regional, and national resources for compute, particularly in that HPC batch workflow workloads. And those systems are pretty much standardized. In the networking space, we have over 200 universities at the 40+ gigabit scale, and of course, network is very standardized as well. But in the storage space, storage is mostly balkanized, right? The National Science Foundation doesn't provide many storage services at the national level. They tend to fund campus storage, which more often than not is a POSIX storage system, right? Sometimes proprietary, attached to an HPC system. However, most science projects are across institutional boundaries, and we have a need to share data. And so what you end up doing for these projects is either getting access to another campus's VPN and IAM solution, but more often than not, you end up doing shadow IT and setting up a Google Drive or a Dropbox or a Box or a OneDrive, and you probably have multiple of all these for your different projects. So OSN tries to do that by building a cyber infrastructure storage service that provides low-friction data sharing services. So the Open Storage Network is our national resource for sharing open scientific data. We have a distributed infrastructure and governance with simple and flexible access and management controls. So here's a map of our infrastructure throughout the United States. Now, initially, we started with some funding from the National Science Foundation, Dalio Philanthropies, and the Schmidt Future Foundation, and that funded our initial pods, which are along with our initial founding members and also participants on the operations side of OSN, and that's San Diego Supercomputing Center, that's NCSA at Illinois, that is Johns Hopkins, that's RINCE in North Carolina, and the MGHPCC. Now with those, we built our original Generation 1 pods, which were about a full rack of equipment, about $150,000, and provided about a petabyte of usable space. But now, since that NSF project has ended, and we've developed the infrastructure around supporting these in sort of an automated CI/CD fashion, we now allow other organizations to buy their own hardware with their own funding, and then we federate it into the network and provide sort of object storage as a service. And so we've been very successful over the last couple of years getting funding, particularly from the CC STAR, the Campus Cyber Infrastructure under SICE at the NSF, under their data storage program. So we have 4.5 petabytes going in at Caltech libraries later this year. We just put in production some storage at Rice. We have a storage solution for Alabama A&M that was funded by that program. We have 3 storage pods, or 4.5 petabytes of storage for the American Museum of Natural History in Manhattan. The University of Rhode Island has a pod here at Markley Data Center in Boston. And then the U.S. Geological Survey has 2 pods, or 3 petabytes of storage at our data center at MGHPCC. And so when talking about data, it's often good to look at the FAIR guiding principles, right? Findable, accessible, interoperable, and reusable. And we've historically focused on the accessible part, right, sort of standard protocols for authentication and authorization. And we have some other activities going around to automatically process storage buckets and generate a persistent metadata view of that bucket. And we also have some activities around registering our OSN-provided storage with some national data location services to make it findable. But historically, we have focused on the access part of it. And so basically what OSN is, it's S3, right? It's S3 storage if you've ever used AWS S3 or another S3 storage. It is a publicly routed data lake. So if you can access the internet from where you are, you can access your OSN storage, right? It's all over this RESTful API riding on top of HTTPS. For authentication and authorization, much like all these web services, it uses an API key pair to access the service. However, we've wrapped that around ColdFront. So earlier, I think it was Christy's talk, who was talking about NERC and the ColdFront portal. We have the same thing here for OSN. We have a ColdFront portal where you log in with your campus credentials via CI logon, and then from there, you can retrieve your bucket URI, your bucket name, and your credentials for accessing a bucket either read-only or read-write. And then through that portal, you can add other users to your projects, and as long as they have a authentication service that's registered with CI logon, whether that's that campus credentials or OrcID or Gmail or GitHub, you can add them to their project, and then they can retrieve their API keys to do their work. For security and data integrity, this is all built on top of Ceph, right? We use 8+3 erasure-coded blocks in the most recent version of the platform to provide reliability and robust data services. And it's high performance. This is all commodity servers. The original generation was about a full rack of Supermicro servers. The current generation is, I think, 60% of the cost, and instead of being a full rack, it's down into 7 U's of space and provides 1.5 petabytes of usable storage. But these are all mostly on 100 gigabit networks on Internet 2. A couple of them are at 40 gigabit, and that just depends upon the hosting institute. So the key ideas are a data set is made of a collection of objects. And once you have an object, you now have a URI where you can access that from anywhere. So you either need to use an S3 aware client or code with your API keys, but if your bucket allows anonymous read access, you can access it through a web browser or wget or curl, right? What a lot of people are doing with OSN is they're building project websites using static site generators like Google Pages or Read the Docs. And then their data sets they're putting on an OSN bucket, and then in their static site, their static HTML, which they generated, there's just a URL to download the data sets. And that's one way people are using that to publish data sets. Again, the physical storage, as I showed, is distributed across multiple sites throughout the nation. And we might actually be going international this year. We're talking to some groups in both Italy and Africa who are interested in adopting the open storage network for their solutions. And for the most part, we're located in science DMZs for fast access. We are able to sustain multiple gigabytes a second across Internet 2 from SDSC to our data center in Holyoke, Massachusetts. So usually the bottleneck is going to be on your side and not through the storage network. In fact, from AWS US East 1, you get better performance to our pods at MGHPCC than you do to S3 in their own region. And that's a discussion for another day. So the way data sets are set up, there's a couple of options. Now, Ceph can do a ton of things, right? And S3 can do a ton of things. But we've really reduced the feature set that we support. This is mostly a volunteer effort. And now that we've opened this off and offered this as a service, we don't want to be victims of our own success. So we have a very small subset of the S3 API which we support, and we're constantly adding features as time allows. But right now, we have two sort of data set types. One is open access data sets, where it's anonymous, read-only, anyone can read it, and it's writable by anyone who has the read-write API key pair. Or we have protected access data sets, where it's readable by anyone with a read-only API key pair, and writable by anyone with a read-write API key pair. We do not generate per user key pairs, we generate per bucket key pairs, again, to reduce our administrative burden. Now, as I said, originally, OSN was developed as this low friction data sharing platform, whether that's sharing data with the community or that's sharing data with a project. It was basically meant to replace Dropbox, Box, Google Drive, et cetera. However, as projects started getting used to the concept of the object store, they started building services on top of OSN and not just using it as a means to exchange data. And OSN has now become part of several universities' critical CI plans, right, as a building block for building CI services. So we now allow universities, nonprofit organizations, or government labs to purchase their own OSN storage appliance. So we provide you the BOM, the bill of materials. We very carefully control every aspect of it. We don't allow you to buy part of a storage pod or expand it. It's all quantized, right, in discrete clusters to, again, reduce our administrative burden. And the way we've set up OSN maps really well to the MOC and the open cloud vision that John discussed this morning. So if you remember in John's talk, he brought up this open cloud concept slide where he talked about what defines the open cloud. And the OSN project maps to that vision extremely well, and we have sort of our own way inadvertently also combated that cathedral trend that is in commercial cloud storage. You buy the hardware, you own the infrastructure. Our distributed team of sysadmins, we maintain it for you, right? You get the servers, we mail you a USB drive, a thumb drive. You put it into each of the 3 servers, and that bootstraps them. And then from there, we run Ansible playbooks, and it's all set up, and we run it for you. The operations of OSN is all transparent. We have a weekly implementers team or sysadmin team meeting, which you're welcome to attend. And all of our Ansible playbooks are on GitHub, right? We're very CI/CD DevOps focused. And our cost recovery model, again, we're nonprofits, we're not making any money, we're actually losing money running OSN, because again, it's mostly done on volunteer time. But here is just a comparison of the cost of OSN versus 2 cloud providers. One is Cloudflare and one is AWS for their S3 services. Now, what you can see is we're actually about 10% the cost, not a 10% discount, an order of magnitude cheaper than S3 for more performance. This is actually based on some older numbers, but right now we're around that $16 to $17 per terabyte per year of supported storage. Now that doesn't include the data center hosting costs. If you rate that at the cost of what we charge at MGHPCC for colo, it's around $19, $20 per terabyte per year, which is extremely cheap for a full service storage solution. So what can you do with OSN and how people are using it today? Well, originally it was very much check-in, check-out semantics, right? Pull down data, work on it, check it back in. rclone is like rsync for cloud storage, command line tool, amazing tool. CyberDuck is a GUI, right, for drag and dropping your publicly accessible data lake. We have a lot of people who are using it with Globus, right, to basically make that as a way for creating a cache for scratch space, right? All our national and most campus HPC systems have a parallel scratch space with a Globus endpoint, but that data's purged every 14 days, right, of inactivity in order to keep scratch spaces clean. And so you can use OSN as a virtual cache as you're doing work. The other nice thing about Globus is it gives you ACL access, right? You can create subdirectories. They're not really directories, but you can create subdirectories in it and then restrict access to individual users or projects within your bucket through Globus. Now that people have started to use OSN a lot, they're starting to update their software and their tooling to be S3 native, right? Reading and writing directly to S3 as opposed to pulling it down to POSIX, modifying it locally and checking it in. And so in the Python ecosystem, there's some native tools which require to use their file formats like ZAR, but there's also FSAILs or file system abstraction layers where you continue reading and writing the file as if it were local. Just upstream in your Python, you say, instead of writing locally, intercept all those I/O calls and write it and read it to OSN. And the package that I use to do that has a great name. It's called Kerchunk. which is a really nice package to work with. And there's these similar fsail concepts in both Julia and R. You can mount S3 storage as a POSIX file system. I really don't recommend you do it unless you have a legacy application which has very modest I/O demands, like S3FS and rclone. Just that fuse abstraction really slows it down. JuiceFS actually puts a file system on top of S3, which performs really well. There, you can no longer use a native S3 tool to read and write to that data because JuiceFS has put the equivalent of a file system on it, but it's still very powerful. There's some really nice data version control tools which people are starting to use, especially in this generative AI space where tracking your data lifecycle and provenance is really important. You can use OSN with GitLFS. You can use it with DVC, which is data version control. It's another command line tool for versioning your data. Or LakeFS, which provides multiple APIs for reading and writing data on top of S3. So earlier today, someone asked about data warehousing. So LakeFS allows you to have interfaces to like Hive or Iceberg or Spark in the Apache ecosystem, and many other open source tools where you write their native API to the LakeFS middle layer and then use OSN in the backing store. And finally, multiple universities are using OSN as the backing store for their data management platforms. Delaware is putting into production a large 3 petabyte Dataverse solution. Caltech Libraries is using Invenio RDM, which is the open source version of the software which runs Zenodo, which is CERN's data management platform. And then Clouder is written and offered by NCSA, and iRods by our partners at RINC. And so how do you get started on OSN? Well, first, if you want one of our buckets throughout the nation, and you work within the NSF Access ecosystem, you can go to accessci.org today, request up to a 50 terabyte allocation, and get a bucket in a couple of days on one of our pods nationwide. We also have a pod in our data center, which is funded by OSN and the MOC team. And so it's our test pod, but you can get a bucket there to start experimenting with MOC and NERC resources that are backed by OSN storage. And finally, you can buy your own pod. If you're interested in buying your own pod or partially interested in purchasing part of a pod, I now have several projects who need more than 50 terabytes, but don't quite need the full 1.5 petabytes, who are interested in splitting partial pod purchases with other projects. Just reach out and let me know what I can do to help. And with that, I'll take any questions. There's one back there. Oh, okay.
On the requirement for access to large data sizes, like if I have a project where I actually want a bunch of, I don't need 50 terabytes of space, but instead I need like 50 gig buckets that are separate with different access policies. Is that still appropriate, or?
Yes.
Okay.
Yes, that's the way it works. So basically through access, you would get a storage allocation up to 50 terabytes. And then that'll give you your max capacity or quota on the storage network. And then through the Coldfront portal, you can divide that into n number of buckets that sum up to 50 terabytes.
Okay, thank you.
Yeah. I have a lot of projects that I've worked with in a previous lifetime who were all IoT and air quality sensors, and they use that to aggregate small CSV files, right, that they then publish on a GitHub Pages website. So yeah, perfect use case. All right. Yes?
Could you go back one slide, just a second? So you had the hardware right there is $100,000 for 1.5 petabytes. That's $60, $66 per terabyte. And you said earlier that you could do it for 20.
That's for 5 years. So it's $100,000 for the hardware, right? And then $50,000 for the support, right? So that's $150,000 over 5 years.
Oh, and your earlier number of $20 per terabyte was per year.
Exactly.
For 5 years.
Yeah.
So it's 100 actually. So the hardware is costing $66, and you're charging.
The hardware
100.
buys you 1.5 petabytes of usable space, and in the graphs I said I did it per terabyte, right? So it's roughly if you're buying a pod today, it's $80,000 for the hardware, though that we expect that price to go up, and we can talk about it offline. But a pod today is $80,000, and then you send us $10,000 a year. So that's $130,000 over 5 years for 1.5 petabytes of usable space, which is less than $100 per terabyte per 5 years.
Which is the $20 per terabyte. Yeah, because, so my question was going to be, like, what is the fraction of the hardware versus the operations and the overhead? And so it sounds like it's something like 65-70% is the hardware, and then 35% of the operations. But you're not charging for personnel time because people are doing it on nights and weekends, volunteer.
The important asterisk there is our current policy is it's $10,000 per site per year, not $10,000 per pod per year. So if you buy 4 pods like AM&H, it's still $10,000 per year. The operations doesn't scale based on the number of pods you buy.
Okay. Yeah, and so just as an interesting data point, so when I was at EMC, we were building these systems to sell to customers, and then customers often we were often competing against the cloud. Mm-hmm. And our rule of thumb guess was that like AWS is about half the money they're spending on the equipment, and the other half they're spending on operations and networking and power and storage and whatever. So you're able to do better than that by, working for free.
Yes, by working for free, and they can't buy anything they want, right? I've generated a solution ID with Dell, and so you basically provide the solution ID, and it gives you one set of hardware, and thus the same set of playbooks work everywhere, right? So, and then reducing the feature set that we support, right? All right. Any other questions? All right. Thank you very much.
So actually, first of all, it's really cool to see where you guys have gotten to. I'm very excited about this. I guess a few things I'd just like to, over long term, we should get LSVD running on top of this now that you have that. And I guess 2 other things is one of them is that you have the location in some sense defined across all these pods. That's where you get the allocation, which is sort of consistent the way we talked about things is you get in sort of our vision of the open cloud, if you get an allocation in an area. But it also feels like we should be able to use this for caching things, right? So, if we take further what we've been doing with D4N and we talk about geo-replication, then you access it at the nearest access point. And this is going to take a long time to do, but I'd really love to start figuring out how we can do that. And then I guess my last question, and then I'll let you answer, is not that I really had questions, but is right now you're charging at this unit. Is there a value at some point for us to go sort of the consumption-based charging to end customers, like to integrate that model? How do the 2 relate?
Well, so John just walked in behind you, so if we're changing the cost model, you can talk to him. But no, I'm just kidding.
Walking into a room where Ron and Chris are having ideas is like a terrifying experience.
Yeah, we're planning your demise behind your back.
You can answer the question now.
So he was asking about OSN going more to a consumption model as opposed to a per appliance model.
Not moving to it, but just
just augmenting it, right?
Something.
I think all things are possible, as you know, but it's been really nice keeping it simple. Yeah. And simple hasn't been trivial.
Yeah, but to answer your question around the caching, yes, I think OSN and the type of technology that spinning disk and S3 provides, as well as the level of resilience, is the perfect backing store, right? And because it's over HTTP, you already have sort of Squid and those type of proxies, which can do a lot of the caching for you if you wanted to grow your own tool. And the D4N tools and along those lines are kind of what we need in this space, right? There are some very nice commercial solutions that sort of do this caching for you. And one of them that I've been playing with is called Versity, which was based on the fork of SAMQFS, which came out of Sun before Oracle bought it, where you basically have a POSIX layer, and on the back end, historically, it's tape. But now you can also do the back end with S3. And the performance, so they have NVMe drives and sort of a local POSIX cache with backing stores that are S3, and then eventually Glacier on the back end. providing something like that and developing something like that around open source software would be an amazing addition to this space. All right. All right. Thank you for, oh, I'll come, I think it's time for lunch, or I don't want to hold people up. Okay, I'll come find you.